Hey everyone, welcome back to The Explainer. I am absolutely thrilled you're here today because we are going to unpack a massive, totally hidden vulnerability that's baked right into the very architecture of the internet. Seriously, we interact with this system thousands of times a day entirely without realizing it, and yet it holds the power to bring the entire digital world to a screeching halt. So get ready, because we are looking at the invisible engine of the web.
Okay, let's dive into this. Picture this scenario. You wake up one morning, grab your phone, and realize Google just won't load. You try YouTube, nothing. Facebook is completely offline. Even your company's internal portal is just throwing a bunch of errors. Your very first thought might be that the digital apocalypse is here, or at the very least, that the biggest server farms on the planet have somehow simultaneously caught fire. But here's the crazy secret. Those servers are actually perfectly fine. The real culprit is something much smaller, much quieter, and vastly more critical.
And that silent culprit behind this digital apocalypse? It's DNS. So here's our investigative roadmap for today. First, what exactly is DNS? Second, real-world DNS disasters. Third, why DNS outages are worse. Fourth, invisible corporate and Kubernetes failures. Fifth, AI pipelines rely on DNS. And finally, number 6, how SREs fix DNS errors.
All right, jumping right into Section 1. What exactly is DNS? Think about your smartphone contacts for a second. If we didn't have phone books and you only knew your friends by their names, say John or Sarah, but you didn't have their actual phone numbers, well, you couldn't call them, right? The internet works the exact same way. You might type google.com into your browser, but computers don't understand words. They need numbers. Specifically, they need an IP address, like 142.250.whatever. DNS stands for Domain Name System, and its entire job is basically just translating that human-readable name into a machine-routable IP address. It is literally the internet's phone book. Without it, making a connection is just totally impossible.
When you hit enter on a web address, you're kicking off this staggering multi-step journey. First, your browser checks its local cache. If it doesn't know the IP, it asks your operating system. Still no? It goes out to your corporate network or your internet service provider. From there, it might travel to the global root servers, then the top-level domain servers, and finally down to the authoritative DNS server just to get that single IP address. And what's absolutely wild about this is that all of this heavy lifting, this massive global treasure hunt, has to successfully finish before a TCP connection even has a chance to start. If DNS breaks here, the rest of the internet might as well not exist.
Moving on to Section 2, Real-World DNS Disasters.
Now, what's really interesting about this slide is looking back at 2016. A company called Dyn, which was one of the world's largest DNS providers at the time, got hit by an unimaginably massive DDoS attack. And the traffic didn't come from a few supercomputers, no. It came from hundreds of thousands of hijacked, everyday IoT devices. We're talking basic security cameras, DVRs, routers, smart home appliances, all roped together into the infamous Mirai botnet. They flooded Dyn with so many DNS queries that the entire system just buckled under the weight. The result of that attack gave us this totally chilling realization. The websites were alive, but nobody could find them. During the Dyn attack, massive services like Twitter, Netflix, and Spotify were completely unreachable for millions of people. But here's the kicker, right? Their servers hadn't crashed at all. The data was perfectly intact. The streaming video files were sitting right there, completely fine. But because the DNS provider was choked out, users literally couldn't translate netflix.com into the right IP address. So the destination existed, but the map was utterly destroyed.
Which brings us to Section 3, why DNS outages are worse.
Let's think about a normal server failure. If a web server crashes, a load balancer simply notices the failure and automatically redirects traffic over to a healthy backup server. Service is restored in milliseconds. You'd barely even notice a blip. But a DNS crash? That's an entirely different beast. Imagine you're driving on a massive, complex highway network. The roads are fine, your car is fine, the city you're driving to is completely fine. But suddenly, your GPS navigation system just goes totally blank. It doesn't matter how fast your car is, you have absolutely no idea where to go. All traffic just stops. That is the devastating power of a DNS failure.
Let's look inward a bit. Section 4. Invisible corporate and Kubernetes failures.
Picture a random Tuesday at the office, where employees suddenly start reporting that they can't log into the ERP system, emails just won't send, and the VPN keeps dropping. Network operations checks the CPUs, the memory, the storage, and it's all perfectly normal. But the services are dead. Why?
Well, because modern applications are giant chains of dependencies. Your front end relies on an API, which queries a backend, which talks to a database, which authenticates via an Active Directory server. And every single step in that massive chain uses DNS to find the next link. If internal DNS fails, that vital chain snaps instantly.
So the crucial point is that this gets even more complex in modern cloud environments. Take Kubernetes, right? The system running most of the world's modern microservices. A lot of newcomers completely overlook DNS in Kubernetes, but it's part of the core infrastructure. If Pod A needs to talk to the payment service, it completely relies on a built-in resolver called Core DNS to figure out exactly where that payment service lives. If Core DNS goes down, every single microservice inside your cluster instantly loses contact with every other microservice. It looks like the whole cluster died, but really, they just completely forgot how to find each other.
All right, Section 5, AI pipelines rely on DNS.
When you send a prompt to an enterprise AI, you aren't just hitting one magic server. It flows through an incredibly complex multi-stage pipeline. Your request hits an API gateway, which talks to an LLM gateway. That then queries a vector database and an embedding service just to get some context. Meanwhile, it's firing off logs to telemetry and storage before finally relying on an agent platform or MCP server to actually execute a task. Every single one of those isolated layers absolutely depends on a DNS resolver to find the next microservice. A single DNS timeout at, say, the vector database layer, that means your incredibly expensive AI pipeline completely fails to generate a response. This is exactly why massive AI platforms are forced to deploy really robust mitigations like Anycast DNS, GeoDNS, and some seriously heavy caching.
Finally, Section 6, how SREs fix DNS errors.
And this brilliantly illustrates exactly why this is so tough. DNS errors are literal masters of disguise. When a DNS failure happens, the application almost never says, "Hey, DNS is broken." Nope. Instead, your dashboard flashes a connection timeout, so the natural instinct is to blame the network. Or maybe you get a database connection error, so you go interrogate the database team. You might see service unreachable. But the real root cause for all of these is so often a hidden DNS query timeout, a missing IP, or a downed resolver.
Because these errors are so incredibly deceptive, mature site reliability engineering teams know they have to monitor very specific DNS metrics to cut through all that application noise. They watch the query rate and response time to spot lag. They heavily monitor NX domain errors, which basically means a domain just doesn't exist, and serve fail errors, which means the DNS server itself actually failed to process the request. They also track cache hit ratios and recursive query counts. When a major incident happens, tracking these precise metrics is usually what points the smoking gun directly back to DNS.
But the future is getting a whole lot smarter. We're moving toward AI ops, artificial intelligence operations platforms. Instead of a human spending an hour trying to decipher some vague timeout error, these AI platforms constantly analyze DNS logs, network flows, and OpenTelemetry data in real time. When the AI detects a bizarre spike in DNS latency correlating with rising error rates, it can directly infer that DNS is the root cause. And even better, it can automatically execute self-healing actions. We're talking triggering a DNS failover, switching resolvers, or doing a massive cache flush without a single human having to intervene. It's a total game changer.
It really makes you realize that the internet isn't just about massive servers and data centers, right? It's overwhelmingly reliant on this invisible engine quietly routing traffic in the background. But that brings us to an incredible, kind of terrifying thought. If a tiny, microscopic DNS error can mask itself and take down global AI pipelines and massive corporate networks, what happens when a single BGP routing error makes an entire country's network completely disappear from the face of the internet? We will be exploring exactly that in our next System Architecture Explainer. Thank you so much for learning with me today, and I absolutely cannot wait to see you next time.